You know that feeling when you write some code, you hit run, and then magic happens? But what is that magic, really? Well, today we're going to pull back the curtain on that whole process and explore one of the most essential tools in all of software development. So, when we write code, right, we use languages like C++, Java, or Python. And we call these high-level languages because, honestly, they're designed for us, for humans. They use words and logic that make sense to our brains, kind of like following a recipe. But here's the catch. See, the computer's brain, its processor, it doesn't have a clue what int sum equals a plus b means. It speaks a totally different language. It only understands binary. That's just a long, long stream of zeros and ones. We call that machine code. So to the processor, our nice, readable code is complete gibberish. And that creates a massive problem. So you see the issue here, right? We've got this huge communication gap. On one side, there's us, thinking in these complex, high-level ideas. And on the other side, you've got the machine, which literally only understands on or off, those zeros and ones. So how on earth do we bridge that gap? I mean, look at this. These two languages are on completely different planets. What we need is, well, we need a translator. We need something that can take our instructions, written in a language like C++, and meticulously convert them into the binary instructions that the processor can actually understand and execute. And that special translator, that's what we call a compiler. Now, it's super important to remember. A compiler is a piece of software, okay? It's a program, not some physical chip. And its whole job is to take all of our source code and translate the entire thing in one single go into machine code. In this analogy, it's absolutely perfect. Imagine the computer gets a message it just can't read. That's our source code. The compiler is like that amazing bilingual friend who steps in and says, "Don't worry, I got this." It translates the entire message into a language the computer completely gets, allowing it to finally do what we asked it to do. All right, so we know what it is, but how does it actually work? This whole translation process isn't just a simple one-step thing. It's actually more like a factory assembly line, where our code gets passed down the line, getting transformed at each and every stage. So first up, the code hits the lexer. Think of the lexer as breaking down our sentences into individual words or tokens. Then it goes to the parser. The parser is like a grammar teacher. It checks if all those words, those tokens, are arranged in a way that makes sense according to the language's rules. Once it gets the green light, the code generator steps in and turns that grammatically correct structure into the actual machine instructions. And finally, because our programs are often built from lots of different files, the linker comes in at the very end to stitch everything together into one single ready-to-run program. But here's where it gets really cool. A compiler isn't just a translator. No, it's also a super strict quality inspector for your code. And honestly, this might be one of its most important jobs. Yeah, before it even thinks about making that final program, the compiler goes through your code with a fine-toothed comb looking for mistakes. Did you forget a semicolon? Misspell a command? The compiler will literally halt the entire process, flash an error message at you, often telling you exactly where you went wrong, and it will flat out refuse to create a broken program. Pretty helpful, right? Okay, so there's another super important thing you need to get about compilers. The translation it does, it's not a one-size-fits-all kind of deal. The machine code it spits out at the end is actually tailor-made for a very specific type of computer and a specific operating system. And you can see that right here. If you compile your code on a Windows machine, you're going to get a .exe file, and that .exe will only run on, you guessed it, Windows. But if you take that exact same code and compile it on a Mac, you get a .app file, which only works on Macs. The output is completely platform dependent. And yeah, it gets even more granular than just the operating system. The compiler is also targeting a specific CPU architecture. So a program that's been compiled for a modern 64-bit processor, it probably won't run on an older 32-bit one. The compiler really needs to know the exact specs of the machine it's translating for. So let's wrap this all up. The compiler is that essential bridge, the critical link between our human creativity and the raw power of the machine. It's this incredibly smart translator, a meticulous error checker, and a master builder, all rolled into one powerful program. It takes our ideas and turns them into the only language the computer truly understands, so it can finally bring our programs to life. But that leaves us with one last really interesting question. We know a compiler translates the entire program all at once, before you can even run it. But what if you didn't want to do that? What if you wanted a translator that worked on the fly, processing your code just one line at a time as it runs? Well, a tool like that actually exists. But that's a story for another time. See you then.